In this video, let us try to solve a couple of complex problems related to product to sum or sum to product formula application. So in the first question, we have to prove that if sin x is equal to n times sine of x plus 2 alpha, then tan of x plus alpha is equal to 1 plus n divided by 1 minus n times tan alpha. So let's give a try and solve the first one now. So in the first one, the information that we have is sin x is equal to n times sin x plus 2 alpha. Then using this, we have to prove tan of x plus alpha is equal to 1 plus n by 1 minus n times tan alpha. Now here, let's rearrange this question. So we can write this as sin of x plus 2 alpha. Let me write alpha in a different way so that you can easily identify what is 2 and what is alpha. And by sin x, this is equal to 1 by n. Now, we will use a rule of mathematics, the ratios, called Componendo Dividendo. So what does this rule say? If the ratios of a plus b, a by b is equal to c by d, then a plus b by a minus b is equal to c plus d by c minus d. So we'll apply this logic to our equation here. So this will be, if you consider this as a, then this as b, then this as c, and this as d. So we can rewrite this as a plus b is sin of x plus 2 alpha plus sin x. This will be our numerator. And sin of x plus 2 alpha minus sin x, and c plus d is 1 plus n, and c minus d is 1 minus n. Now this is of the format sin c plus sin d, and this is sin c minus sin d. So let's apply the formula now. So this will be 2 sin c plus d by 2, which is 2x plus 2 alpha by 2, cos c minus d by 2, which is x plus 2 alpha minus x by 2, and the denominator would be 2 cos c plus d by 2. So 2x plus 2 alpha by 2 sin c minus d by 2. So x plus 2 alpha minus x by 2. So let's simplify this. We would get 2 times sin of x plus alpha and cos of alpha, and the denominator would be 2 times cos of, and all the way this is equal to 1 plus n by 1 minus n. We should not forget that. So in every step this is 1 plus n by 1 minus n, and the denominator would be x plus alpha and sin alpha. So we can cancel the 2. So this would change to tan of x plus alpha times cos alpha by sin alpha is cot alpha. So we can write it as 1 by tan alpha is equal to 1 plus n by 1 minus n. So we just move the tan alpha to the other side and we get our proof. Tan of x plus alpha is equal to 1 plus n by 1 minus n times tan alpha. So this is one of the unique questions we solved using Componendo Dividendo rule. You can apply this in more and more problems where we find a ratio like a by b is equal to c by d. Then a plus b by a minus b will be equal to c plus d by c minus d. So let's try the second one now. Now the second question is interesting. Here we have to prove that cos a plus cos b divided by sin a minus sin b, the whole power n, plus sin a plus sin b by cos a minus cos b, whole power n. This is equal to 2 times cot of a minus b by 2 to the power n when n is even and equal to 0 when n is odd. So let's see how we can solve this. So here we see that it is of the format CosC plus CosD, and the denominator is sin C minus sin D. Similarly, it is sin C plus sin D and cos C minus cos D. So we are going to apply that formula now to convert these sum and differences to products. So the first term will change to 2 cos C plus D by 2. So this is a plus b by 2 and cos C minus D by 2. So a minus b by 2. And in the denominator, we would have 2 cos a plus b by 2 and sine of a minus b by 2, and this power n. Now the second term would be 2 sine c plus d by 2, so it is a plus b by 2 and cos of a minus b by 2, and the denominator we would have, it's a unique application now, this is 2 sine c plus d by 2, so this is a plus b by 2 and sine of b minus a by 2, because cos C minus cos D has a unique formula which is 2 sine C plus D by 2 and sine D minus C by 2. Now this is power n. Let's simplify this. We can cancel 2 here and also we can cancel the cosine value. And in the next term, we can cancel 2 and we can cancel the sine value. So here, the first term would change to cotangent of a minus b by 2 power n. Now the second term is interesting. So here, to change this to cotangent, we need sine of a minus b. So we can rewrite this as cos of a minus b by 2 divided by minus sine of a minus b by 2 and this power n. So this will be cot of a minus b by 2 power n, then plus minus cot of a minus b by 2 power n. So our equation would change to cot of a minus b by 2 power n, then plus minus 1 power n times cot of a minus b by 2 power n. Now cot of a minus b by 2 power n is common between these two terms. So let us have that as a common term. So we'll write this as cot of a minus b by 2 power n times 1 plus minus 1 to the power of n. Okay, now let's go back to the question. So we have to prove that it is 2 times cot a minus b by 2 power n when n is even and 0 when n is odd. So let's see what we have here. So here if n is equal to 2, which is even. So what would happen in that case? We would get this portion as 0 because it would be 1. No, we would get 1 plus 1. So we would get this as 2. So when n is equal to 2, the value would be 2 times cot of a minus b by 2 power n. Now if n is equal to 1, we would have this portion would change to 1 minus 1 because minus 1 to the power of 1 is minus 1. So this whole thing would be multiplied by 0. So basically we would have a minus b. It will not be 2 times cot. It will be cot of a minus b by 2 power n multiplied by 0, which is equal to 0. So this is how we can prove that the value of n when it is even, it is 2 times cot of a minus b by 2 power n, and when n is odd, it is 0. So this is one of the unique problems we have solved in this playlist. Please share this with your friends so that it's useful to them too. And I'll see you in the next video. Thank you so much for watching.